Welcome to Code Report. I'm your host, Connor Hoekstra. Last week we had 5 contests that took place, 3 from Code Forces. On Wednesday we had round 531. On Friday we had Educational 58, and on Sunday we had round 532. We also had from Hacker Earth the Hour Storm number 7 and from LeetCode contest number 119. And throughout the week we also had the Code Chef Long Challenge for January, which at the moment is just wrapping up, and I will be posting 3 or 4 solution videos to problems from that once the contest is over. Taking a look at the top 10 leaderboards, here they are for the 5 contests that happened. There were only 2 individuals that placed on multiple top 10 leaderboards, and those were Yui and Neil Wu, who placed 2nd and 5th in the Hacker Earth Hour Storm contest, respectively, and 3rd and 4th in the LeetCode contest. Other notable users or familiar users that we've seen before, we had in 7th Natsugiri and 9th John Cram in the LeetCode contest, and we also have KMJP in 6th. And this individual typically we see in the Code Forces contest, but I checked the profile and this is their 4th contest. So it looks like there are some individuals that have typically competed on the Top Code or Code Forces sites that are slowly moving to LeetCode. In today's video, we will be quickly covering the first problem from the LeetCode contest number 119 entitled K Closest Points to Origin. The problem states we have a list of points on the plane. Find the K closest points to the origin. And in this problem, it states that this is Euclidean distance, which is what we would expect by default, and that you may return the number of points in any order that you want. So if we take a look at the 2 examples that LeetCode provided us with, here they are. So you can see we have a list of lists or a vector of vectors representing the x, y sort of coordinate points, and then k, which is the number of points that it wants us to return. So if we take a look at both of these examples visually, the first one looks as follows. So here is our point -2, 2, and here is our point 1, 3. So if we calculate the distances to the origin, we're going to end up with root 8 for this point and root 10 for this point. So this one has a smaller distance to the origin, so we're going to return this one, which is what the answer says. And for this second example, we're returning 2 points and it gives us 3. If we graph this, it looks as follows, and we're going to end up calculating the distances and returning 3, 3 and -2, 4, the point over here. So this problem is pretty straightforward, and we're just covering it so that I can highlight one of the C++ STL algorithms that can be used to solve this problem very nicely in less than n log n time, which is what I've seen for most of the solutions posted online. So let's take a look at our C++ solution. So we can see here we have our function k closest, which takes 2 parameters, our vector of integers representing the x, y coordinates of the points, and an integer k telling us how many points we want to return, which is going to be returned here in our vector of integers. So on our first line, we have our first generic lambda, which is calculating the distance. Note that for this problem, we actually don't need to use the square root because comparing just the sum of the squares of the coordinates will be equivalent to comparing the square roots of those, but just for demonstrating the actual problem, we're leaving the square root there. And in our second line, we have our second generic lambda, which is a custom comparator comparing the distance of the 2 points. And on our third line, we have our STL algorithm, which is partial sort. So this takes a range defined by the first and third parameter, which are 2 iterators. And then the second parameter defines how many elements of that range do we want to sort. So if we just pass plus k to our begin iterator, it'll only sort the first k elements of a fully sorted range. So that doesn't mean that it's only sorting the first k elements of the range that you give it. It's saying that given a range of 10 elements or 100 elements, if you tell us 3, we're going to sort that range such that we have like a fully sorted first 3 elements of that range. And if we pass it the custom comparator, it'll sort these elements based on the distance to the origin. And so once we've done this, we can basically just construct anonymous or unnamed vector of integers using a range constructor and return this. So for those of you that didn't know partial sort exists, it's there. It's just sort of a different implementation of the sort algorithm. And the reason you want to use it is because it gives us better time complexity. So the actual spec Specification says that it's less than linear arithmetic, but then it goes on to say that that's approximately equal to n log k, where k is the number of elements that we're actually ending up sorting. So this is a good algorithm to know if you didn't know about it already. And I apologize about the second semicolon here. Taking a look at the contests happening next week, we have 5 of them, 2 of them being from Topcoder. On Tuesday, we have SRM 746, and on Saturday, we have SRM 747. On Friday, we have from Hacker Earth the start of the January Circuits contest. On Saturday, we have from LeetCode the weekly LeetCode contest number 120. And on Sunday, finishing off the week, we have from Code Chef the January Cook-Off contest. As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.